Hello everyone, welcome to video lecture on textile chemical processing, and this is Dr. M. Gopalakrishnan, head of the Department of Textile Technology. Before going into today's topic, let's see some pictures related to our topic. So the first picture, that is bleached with sodium hypochlorite, and the second picture, which is bleached with hydrogen peroxide. So there is a difference in whiteness. So both are bleached, but after some repeated laundry, the first sample is looks duller in that becomes yellow in nature. Whereas in second sample, so that looks brighter, and it doesn't change the color, doesn't change the whiteness after repeated laundry. So that's the difference between the sodium hypochlorite and hydrogen peroxide bleaching. So today's topic is hydrogen peroxide. So hydrogen peroxide is a universal bleaching agent because you can use almost all of the fibers. You can bleach cotton, you can bleach synthetic fibers like nylon, polyester, and you can bleach wool, silk, and other animal fibers. So because of that, it is called as a universal bleaching agent. Whereas if you take sodium hypochlorite bleaching, you can't bleach silk and wool, and even polyester you can't bleach with the sodium hypochlorite. So because of that, hydrogen peroxide is called universal bleaching agent. Moreover, the hydrogen peroxide is stable in wide range of temperatures. You can bleach at 80 degrees Celsius, 100 degrees Celsius, or even you can do it at 130 degrees Celsius. So that is the difference between sodium hypochlorite and hydrogen peroxide bleaching. Bleaching with hydrogen peroxide, that is H2O2. Hydrogen peroxide is gradually replacing other oxidizing bleaching agents for its dominance because of it's a simple product. It is a product of water and oxygen, and it is eco-friendly in nature. And it is more versatile bleaching agent. You can bleach almost all the fibers. It can suit for both batch process and continuous process, and it is more stable in wide variety variation in temperatures, and it can be suitable for all kind of machines. And all the fibers are bleached with the hydrogen peroxide, so it is called universal bleaching agent. So because of these properties, the hydrogen peroxide is widely used as a bleaching agent for most of the textile materials. And hydrogen peroxide is applied as concentrated solution in a dark container. So you should not expose the hydrogen peroxide to sunlight. So you have to keep the hydrogen peroxide in a closed container with resistant to UV light. And the mechanism of hydrogen peroxide bleaching is hydrogen peroxide H2O2 is converted into H plus HO2 minus, and again this HO2 minus is oxidized into HO minus and nascent oxygen. So this nascent oxygen is the responsible for bleaching of textile materials. So this hydrogen perhydroxyl ion, so that is responsible to produce the nascent oxygen. So this perhydroxyl ion is very important for hydrogen peroxide. So this is the agent that converts into nascent oxygen. So perhydroxyl ion is very important for hydrogen peroxide. and the redox potential for hydrogen peroxide is around 8 for 10 to 840 millivolts. So it is lesser than the sodium chloride or sodium hypochlorite. So the bleaching action is slightly lesser, and the bleaching takes place only in a stabilized condition. So the hydrogen peroxide is very fast. That means it will oxidize in a very fast manner. So you have to use some stabilizer to control the oxidation. Otherwise, most of the hydrogen peroxide will oxidize, and it won't oxidize the natural coloring matter. And you can stabilize with some alkaline. You can use sodium silicate or sodium hydroxide as stabilizer, and most widely used stabilizer is sodium silicate. And this is the reaction: H2O2 plus HO minus, again HOO minus plus H2O. This HOO minus is the perhydroxyl ion, and that is responsible for producing the nascent oxygen. So this reaction is takes place only in alkaline medium, and that oxidize the natural coloring matter. This reaction takes place at alkaline medium, and above 10.8 pH, the formation of H2O2 minus ions is so rapid. So the decomposition to liberate oxygen gas. So that means it will escape from the bath, and it won't oxidize your natural coloring matter. So you have to keep the bath at alkaline medium between 10.5 to 10.8 pH. So above this range, the reaction is so fast, and that may escape from the fabric. And the accelerators used in hydrogen peroxide bleaching. So there are three accelerators are used. One is activator, and stabilizer, and sequestering agent. So activator is normally you have to activate the hydrogen peroxide bleaching. Commercially available hydrogen peroxide is stabilized at acidic pH. So it is more stable in acidic medium, and it is more rapid in alkaline medium. So you have to use some alkali to activate the hydrogen peroxide. So normally you have to keep 10.5 to 10.8 pH. So for that purpose you have to use some alkali. Normally sodium hydroxide is used for this purpose. And the next one is stabilizer. So this is very important for hydrogen peroxide bleaching, because the perhydroxyl ion is so rapid, and it may escape. That means it may convert it into oxygen gas. So you have to stabilize the reaction. You have to slowly you have to release the perhydroxyl ion. So for that purpose sodium silicate is used to stabilize the hydrogen peroxide. So when you use sodium silicate, it will form a complex with perhydroxyl ion, and that will release the perhydroxyl ion in a slow manner at elevated temperature. So only when it reaches the particular temperature, it will release the perhydroxyl ion, and that is also a controlled manner. So it will release very slowly. And the sodium silicate is also providing a buffering action, and its solution is colloidal in nature. The stabilizing action of sodium silicate is improved by calcium and magnesium ions. Hence, water molecule of hotness between 2 to 5 degrees is recommended. So you have to use a slight addition of calcium and magnesium ion in the water, so that it will improve the stabilizing action. and it is very difficult to maintain the colloidal form of silicate in industrial process, and it may deposit over the goods, or it may deposit over the machines, and that will form horse on fabric, and some rubbing on machines. So this should be avoided. Because of that, they are nowadays they are going for non-silicate based stabilizers, and deposition on equipment may spoil the machine, and that may be abrasive in nature. And you can improve the horse field by increasing the number of washing. So that's for fabric. Sequestering agent. So normally hydrogen peroxide undergoes heterocyclic fission, resulting in the formation of perhydroxyl ion. So this is the normal reaction that we want for bleaching. But in the presence of metals or UV light cause H2O2 undergo homolytic fusion to two hydroxyl radicals, OH radicals, so uh, that increases the rate of oxidation, and that decompose the hydrogen peroxide. So this type of reaction is called catalytic effect, and the rate of decomposition is very high, and that attack the cellulose, and that form oxycellulose. That means um, poor cotton fabric. The strength of the poor fabric is reduced. So the formation of oxycellulose will reduce the strength of mechanical properties of the fabric. So in extreme cases, holes are produced due to this effect. So due to localized effect, and to minimize the effect of metals on bleaching, so to avoid the catalytic decomposition, we use a sequestering agent. So most of the sequestering agents are polyphosphonate, and polyhydroxy carboxylic acid, and amino polycarboxylic acid, phosphonic acid, and polyalkylic acids. And this is the structure we have given: DTPA, diethyl triamine pentaostic acid, and ETDA, ethylene diamine tetraostic acid. So these are most commonly used sequestering agent. uh, it will reduce the hardness of the water also, and it will minimize the effect of metal on oxidation is also reduced. And effect of pH. So in acidic pH, H2O2 is more stable, and there is no bleaching takes place in acidic pH. And when you increase the pH to alkaline, the rate of decomposition is increased, and that will bleach, or that will oxidize your natural coloring matters present in the cotton fiber. And on the other hand, the effect of concentration of sodium hydroxide in the bleaching doesn't have much influence on bleaching effects. So here the graph shows the effect of sodium hydroxide. So when you increase the sodium hydroxide, it will increase the reflectance value to a maximum level. So the effective range is 2. So after that, the reflectance value is decreased. So it doesn't influence much on reflectance. And the effect of temperature. In practice, the bleaching of cotton is carried out around boiling temperature, 90 to 100 degrees Celsius. However, you can increase the bleaching temperature for a faster process. So, for a rapid process, you can increase the temperature in a pressurized equipment. You can go up to 120 degrees Celsius or 130 degrees Celsius. That will decrease the time of process. However, you can do the bleaching at 80 degrees Celsius. So subsequently, it will increase the time of process. So advantages of hydrogen peroxide. So it is a universal bleaching agent. It can be used for bleaching of natural, synthetic, and blended fabrics. It is possible to combine scouring and bleaching also. So you can combine scouring and bleaching in a single bath. And no anti-chlor treatment is required for hydrogen peroxide because there is no chlorine involved. So it is non-corrosive and does not produce unpleasant odor as like in sodium hypochlorite, and no AOX problem, so no harmful byproducts. So residual size and wax are also removed by hydrogen peroxide bleaching. And disadvantages. So use of silicate as stabilizer has a risk of silicate stain on the fabric and machine. So and it will influence the uh, removal of sludge in wastewater treatment is also difficult. Catalytic damage to cotton is also occur in hydrogen peroxide bleaching. So this can be reduced by using sequestering agent, and it is not effective as like sodium chloride for synthetic fibers. And assessment of bleaching efficiency. So there are different methods are used to assess the bleaching efficiency. One method is comparing the fabric with the standard white. So mostly bleaching is assessed based on the whiteness. So you have to compare your sample with a standard magnesium oxide or barium sulfate sample. So that is the pure white. Magnesium oxide stone or plate is we consider as 100%. So you have to compare with the magnesium oxide plate with your of your sample, and you have to denote. So this magnesium oxide produces 100% reflectance at all wavelengths. For bleached samples, the reflectance at 460 nanometers is used. So that is the blue region. So that is that we want to measure the whiteness index of the bleached sample. So the unbleached cotton shows the reflectance of 55%, which is increased to 83 to 85% on bleaching. So the bleaching will improve the whiteness to 83 to 85% from 55. So other whiteness calibrations also used to assess the bleaching efficiency. For example, W Harrison and W Stephen. So this is the formula to assess the whiteness index. And R430 refers the yellowness, and which reduces the white. So and R670 is whiteness and R430 is yellowness. And other method you can use colorimetric method. And you can use a computer color match Hunter Lab whiteness index W Hunter, and this is the formula. W is equal to L minus 3B. So the formula gives only the blueness and yellowness, but they reduce the redness and greenness. And for bleached fabric, the whiteness index will be around. It is more than 75. Similarly, you can use other formulas or other method also. Stansby, they use all the three parameters L minus 3B plus 3A. So this is the formula to calculate the whiteness index. Similarly, Burger index. So W Burger is equal to 0.333 Y plus 1.060 Z minus 1.277x. So this is the formula used to calculate the whiteness index. And you can assess the damage of cotton. So that is another assessment for bleaching. So copper number. So copper number is denotes the formation of oxycellulose. So normally the first step of bleaching, the cellulose oxidation during cotton's covering or bleaching result in the formation of aldehyde group and hydroxyl group. So these aldehyde groups have a reducing tendency, and that will reduce alkaline solution of copper sulfate, resulting in the formation of insoluble cuprous oxide, which is precipitated on the fabric or cellulose fabric. So the amount of cuprous oxide is formed is proportional to the amount of reducing group, which is expressed as copper number. So the amount of cuprous oxide formed on the fabric is measured by titration, and that indicates the copper number. So this is the test method. So please follow these procedures. And this is the formula to calculate the copper number. And copper number for pure cellulose is around 0.5, for scoured and bleached below 0.3, and for viscose it is less than 1.2. Another method to assess the degradation of cotton is methylene blue absorption test. So normally the cellulose, that is hydroxyl group, doesn't have affinity towards methylene blue dye. So that is a basic dye. When cotton is or cellulose is oxidized, it is converted into hydroxyl group and aldehyde groups. These aldehyde groups again that is converted into carboxyl group, because it has a reducing power, and that will reduce into carboxylic group. The pure cellulose will be in hydroxyl group, and the reduced cotton, so that is converted into carboxylic group. So the degraded cellulose, both aldehyde group and carboxylic group, may be present in the fabric. Hence, there is a need to determine the degree of cellulose oxidation in terms of COOH group content. And you can assess the methylene blue absorption. And if you dye the fabric, that is oxidized fabric, with the methylene blue, based on the absorption of methylene blue, you can denote the degree of degradation of cellulose. So degree of oxidation of cellulose, that is converted into oxycellulose, and this is the dye, and this is converted into carboxylic group. So the carboxylic group is attached with methylene blue dye. So here the attached one. So you can dye the basic dye on cotton when it is converted to carboxylic group. So the amount of dye is absorbed is calculated based on the degree of reduction in concentration of dye in the dye path. And the next one is cuprammonium fluidity. The degradation of a polymer result in reduction in degree of polymerization. So if the polymer is degraded, that means that indicates the dP is reduced. And same concentration, if the degree of polymerization is reduced, then the viscosity of the solution is increased. So based on this relation, you can calculate the amount of fluidity when it is degraded. So you have to so cotton fluidity is measured by using cuprammonium hydroxide solution. You have to mix the cuprammonium hydroxide solution in cotton to a known capacity, and you have to calculate the fluidity test. So based on the fluidity, they will assess the degree of polymerization. So for normal unbleached cotton fabric, the fluidity value is around 2, and bleached cotton it is less than 5, and degraded cotton shows greater than 10, and standard bleached viscose will be around 10. So I hope you have understand the mechanism and chemistry of sodium hydrogen peroxide bleaching, and how to bleach the cotton fabric and other textile materials with hydrogen peroxide, and what is the recipe involved in hydrogen peroxide bleaching, and what are all the advantages and disadvantages of hydrogen peroxide. And so you have, I hope you have enjoyed this class. So we will see in the next class. Thank you.